Hi everyone! Welcome back to FESIG's second session of the 63rd FESIG meeting. Today is the 2nd of April, and we just had our very thrilling and exciting presentation by Jared Rand in the first session, and it was a long, lengthy one because he's got so much to say about, and we were all ears. So here now in the second session, I am going to straight away jump into, well, I'll just share screen as I do traditionally in the PowerPoint presentation. Right, so the second session we'll have the we'll continue with the making of the Buie-Morin Motor Generator prototype that's almost completed now for beta testing and verification. And please, folks, go to Patrick Kelly's website and scroll down to chapter 32, and you see the whole construct that he had mapped out and documented on the Buie-Morin Motor Generator. So Pontus Hassbjer is the key person who had made the prototype. And over to you, Pontus. I'm going to stop sharing screen now. Thank you very much.
I will start sharing some photos of the parts. This is the BLD simulator that is the heart, the drive motor of the generator. I had to measure the centrum of the holes for the outer rotor. So this is how that is done. I measure in millimeters, so if you wonder. The center was 9.9. I had to adjust that a little bit, so it's 50 millimeters. This is the old gasoline engine. Gasoline engine is this part, and this part is the generator. And that one, the old gasoline engine will exist to power this generator. Here I'm taking it apart. Some more picture of dismounting it. These are heavy things. The rotor is about 30 kilograms. And it sits on the shaft on the engine. The engine is the bearing in this end. So I had to machine a new end for that part. And this is how it's done in a turning machine. This is an aluminum plate that I am machining. It takes some time, of course, it's big things, so hours of work. And these are precise, so you have to have a machine shop to do it this way that I did it. Now we are machining the outside.
Pontus, do you think that if
Yeah.
we, instead of using aluminum, that we could use a polycarbonate or laminated polycarbonate?
I don't think that would be strong enough to this because it's a heavy rotor and
Okay.
it's steel or aluminum to support it. Some parts, yes, we can use plastics reinforced. I just took what I had, so that's why I choose.
Yeah, I think your piece of aluminum scrap was a good thickness, and it was big enough that you could cut the piece out to match with the. This goes with the stator or for the rotor?
This is bearing support for a generator and support
okay,
for the stator at the same time.
Yeah, the polycarbonate wouldn't be enough strength then for that.
No.
Okay.
Here's how it looks when it was almost finished in that side. It is mounted in the old housing that was mounted to the gasoline engine with those 4 holes here. And this is the new bearing facility. Here I'm drilling holes and for next and yeah, I had to make some own drills to get there. And here I'm tapping the holes. It looks like this. You tap a hole. Everything has to be aligned, of course, so you need to know what you are doing. There are simpler ways, of course, and that we will also teach eventually. I'm tapping holes in the bearing support. And this is the holes for the starter to the BLDC metal that I showed in the beginning. Here we have a ring that will also be a support to the starter. And here we are turning a new shaft for the generator and coupling for the BLDC metal. I had an issue with a turning machine. the turning head here wasn't really aligned, so I had to realign the whole machine, and that took also time. We go back and forth here to get the dimension that you desire. This was a 40mm shaft from the beginning, and it is 30mm now. You take about 1/4 of a millimeter each time you go like this. This one is the coupling for the BLDC motor. I have just started to machine it. It's a 100mm piece, steel piece. And it has to be machined in one setup almost, because when you turn it in the head, you will have an issue with alignment.
My goodness. Hang on, sorry to interrupt.
Yeah.
Yeah, no, I'm just saying Jared has 4 million people attending his daily meditation call. So we had 80-something people, 90, right? They were, of course, 4 million people knowing. Oh no, so many people jump in, and then they had to leave immediately because his meditation, global meditation, is starting now as we speak. I think started already. That's why they all jump off. So now, not because what we're doing here is of less importance. It's because they have to attend the global meditation. Maybe we should as well. Our listeners and viewers, I forgot to add in the first session that everyone should pay attention to daily meditation, because that's what we are. We are sovereign integral, and we are spiritual royalty, and we've forgotten how to connect within, and Jared's showing the way. So why not join him sometimes? Yeah. Right. Okay.
Well,
over to you. Back to
we
you.
still have 28 in the room, so we're doing pretty well.
We're doing pretty well. Yes.
Yeah.
Thank you. Back to you, Pontus. Sorry.
Okay. Yeah. Here we are drilling the center hole, and then you drill with a smaller bore, and you have to turn it the last part to achieve the right play between the shaft and coupling. Here is the BLDC motor coupling that will fit into the outer rotor. Is this? Here are the magnets, and this one will rotate. This one is made so it can fit both directions, with this end in or out. So that's how it fits one direction. That's how it fits the other direction. And it matches the diameter here. That is the steer diameter. And the holes will also match. I use 6 holes. So these I have to drill out. There are only M6 bolts. That's too small. You see,
Question out of the chat: is there a way to reuse washing machine parts, like using the spider arm shaft, etc., the answer to that real quickly and shortly is we were trying to minimize the used parts as possible, and some of the parts do not interchange. Some things that work on the wash machine don't work on the generator, and so you have to manufacture the different parts.
Exactly. I can share. This is the inner part of the laser rotor, and this is plastic, and the center here is splined, but and metal, steel, and this is how it should look when you're going a bit heavy duty. This would fit in the center in a washing machine. That will not hold up for the part, for high RPM and so on.
For low RPMs, the plastic parts work fairly well. It's when we get into the higher RPMs that we have internal stressors that will actually destroy the plastic from within. It's not just where the holes are, where it disintegrates. It'll disintegrate from the inside of the plastic casting itself.
Yeah, exactly. The generator has a cone that is very sensitive for run out. It will affect the balance greatly. So here we had to grind it also.
So we need equipment to grind.
Yeah, this is grind in a turning machine, and that's a bit more advanced. But this is because we use an old generator that has no bearing in that end.
Okay.
A new one, you can choose the one that has a bearing and the output shaft. And that would make it greatly easier.
For those that are new with this group and what you're looking at, some of the things that we went over was the I lost it. Sorry about that. Oh, speed. If the difference between a inexpensive generator that's like maybe a 5 kilovolt compared to a 30 kilovolt, the cost is not that much different, and the machining is almost that much, the work and the effort and the cost. So the machine work, even if you have to hire it out, isn't that expensive. And so usually in even small communities, there are machinists in the area that are capable of replicating what Pontus is doing.
Yes, of course. There are lots of guys that can do this. Here's the bearing plate, and I'm tapping and drilling holes around it so I can use it for future alternatives. And here in the bottom there has to be some rubber feet also to hold the construction to a bed. Here I'm putting what's that called? Yeah, it's at least it is where the bearing will be hindered, so it can't go out from this plate.
And the bearing is going to be pressed into that opening, that larger circle?
Yeah.
Is it keyed, or is there any other locking, or is it simply pressed in?
It's keyed. I will show that later.
Oh.
Yeah.
Oh, okay.
It is also pressed in, so there's a tight press fit on that one. Some more tapping. Here we have the shaft mounted in the plate, and I couldn't do the key myself, so I had a firm to do that. That's about €70 to do that in the rotor part, coupling part, and the shaft. So that's quite inexpensive. Here you see the cone that I was grinding before, and I made a nut to hold it, to hold a bearing towards the shaft. The other end there is a little bit so it can't go in that direction. You see key, and I have drilled some drilled and tapped some holes here also to hold it to the key. I had to. Oh. I made another one also for other purposes. If my generator is 1500 RPM, and maybe I had to go up in speed, so this is just in case. I have a balancing machine at home, and I haven't used it for 3 years, so I had to rebuild that one. Here we got the machine running. And the coupling and the shaft is in balance in this moment. I have balanced it with a different length of the bolts and matched it to the key and everything. This is very little weight that does not have any effect on the later result. Here it is in the machine, and it's driven by a
It's a belt-driven balancing system.
Yeah, exactly. This is an old machine, but it is very accurate. Before I have balanced turbines for Ariane rockets in this, and they have returned also. Here's the outer rotor mounted, and there's a little bit more unbalanced, so here I still have work to do. And next, after this is finished, will be to dock it together to the generator rotor and balance that complete also.
You realize that the distance between those magnets and the stator of the motor is very tight. There isn't a lot of clearance in there, and any imbalance in the system, in the shafts or in the rotor, will cause a vibration. One, it would cause a difference in the electrical current or the magnetic fields in there. The other is that the balance, if it's not balanced at that high RPM, the machine tears itself apart. The generator tears itself apart. So balancing becomes very, very important.
It's crucial.
Right. Oh, I must remind you that Patrick's here still. So if you need Patrick to explain anything. Hi, Patrick. I hope you hadn't gone to bed yet. Oh, well, you are past midnight
been invited. Now. We've been trying to get a hold of him, and so it's a communication problem.
Yeah.
We'd love to have him stop in, but if not, then Pontus and myself will kind of fill in.
That's wonderful. Was he available earlier on the first session? Oh, it wasn't Thomas Buie. Yeah. Okay. Carry on. Sorry to interrupt.
Yeah, he's in the process of building up his shop, getting it ready, and getting his equipment actually functioning, because he has to do a lot of the same things that Pontus is doing, and he's in a new shop.
And he's also starting his new business. Yeah, that's why he's so busy.
This one is the BLDC motor rotor, and here we got the stator.
Beautiful.
It has a contact there. It's three-phase, could you say? And this one fits in here. And you see, the magnets will hold it. And I can't rotate it now, so that's how it will be fitted.
That's a safe way of storing it, is back in its housing.
Yeah.
You don't want anything damaging those soft contacts all the way around.
No, exactly. This is the bearing part, and here we got a ring to hold the bearing. It will be fitted in here, in this, and in this. Not too so.
Okay.
Down here we will have some rubber parts that will take care of vibration and sound. Now it's being a little bit heavy. These rings go in here. We'll set the distance.
Sergy, you've got a good question, which is, will the extra metal parts affect the operation of the prototype by sucking the magnetic flux? There is always a possibility of that happening, but because it's going to be uniform in size and weight and thickness, the extra polarity, the interaction between the electromagnetic fields and the aluminum should be nominal. But we won't know until after we get it up and running.
No, actually the part will be a bit apart, so it will, this ring will meet up with a plate, of course. And here I have the old generator housing, and this fits in here. And will be bolted from the inside.
Wow.
That's all for now. This is the same drawing that Patrick has on his website. This is only for 12-volt application so far, and the resistors here, they have to be 150 mega ohm. This 33 kilo ohm, and this 1 mega ohm. Because the Arduino board, it will only take 3.3 volts and 1 milliamp. So that's why you have to choose bigger resistors, and resistors should be able to take at least 500 watts over a long period. We will come up with a solution for that. I have found some resistors at Mauser that will do and don't cost a fortune. The rest of the parts we are working on that also, and to update it, and that will come in the near future.
Okay, I just have a question. Can I?
Yes,
Sure.
of course.
Thank you. So the last schematics that you showed there was very interesting, because that's the three-phase driver,
Yeah.
I guess. And did I see 3 MOSFETs there?
Yes, you did.
Yeah. Well, if you could bring it up again.
I do that.
So there is there's a
6.
MOSFET driver there, isn't it?
Yeah.
The first one there.
That's a
that
MOSFET
one?
driver,
Yeah.
ARS 2104, if I recall right.
Yeah.
It's
And then you have 2 MOSFETs.
2 MOSFETs, and these MOSFETs has to be heavy duty. They should at least be 500 to 600 volts, NPN or NPN and PNP. The hard thing is to find the PNP MOSFETs in that range without having heat issues or losing a lot of power in heat instead. And
the MOSFETs are going to need heat sinks, and fairly robust ones.
yeah. And here are also resistors and so on, and capacitor that we also have to look through. And
Well, you have some water cooling systems on the computers that you can maybe retrofit to the MOSFETs.
Yes, there's 2 different ways of going about it. You go with robust, the aluminum FID ones that will basically dissipate the heat that you need in most applications. The water-cooled ones is one more batch of things that can go wrong in the lineup. You have pumps and water in close to the electric. Yes, the overclocking for computers use a water-cooled for their circuitry.
Yeah, that's my point.
Mostly those that are water cooled, they are not so efficient. So we are trying to find very efficient MOSFETs. So that will not be an issue.
You could actually I don't know if the driver is actually affecting the MOSFETs with a big transient, but I don't know if that's the case. But you could use a TVS across the MOSFETs to protect them. That's a possibility.
Okay.
Do you want to explain so that the others that are listening don't understand the jargon? So what's the TVS?
So a TVS is a transient protection for a spike transit transient voltage spike or a diode that shaves off the high transient.
Thank you. Yes.
So it protects the diode within the MOSFET, so it doesn't reach the limit of the MOSFET.
Correct.
So that way you don't blow the MOSFET, and you can drive the MOSFET fairly cool. I know a lot of people, not a lot of people, but I know some people use that trick to protect the MOSFET. So
good.
Okay.
Yeah, we've discussed things like xenon bulb and other resistors and capacitors in that arrangement to dissipate that spike charge. Speed is everything on this. How fast it can get rid of that extra current.
Yeah.
Voltage.
And the speed of the MOSFETs also will be affected. That's also crucial for the operation. On the in here, we will have capacitors also to bring it in resonance. That's how we make this work.
just a little question. Is that series resonance? So it's voltage amplification?
Yeah, amplification, yes.
But when you have series resonance, you have voltage amplification. But if you have parallel resonance, you have current amplification. So
I see your point. I have to try it first.
okay, it's very okay.
Any more questions?
Is the speed of the motor controlled by the incoming DC voltage or through the Arduino, or how is the speed of the motor when you get it? If you want to increase or decrease the on demand?
Yeah, the speed of the motor is controlled by the frequency of the MOSFETs. The voltage in will be about the same, about 400 volts.
What kind of spike or what kind of voltage will reach the coil in the brushless motor?
Yeah, about 400 volts.
Okay.
And high frequency.
What kind of frequency do you expect?
How to answer that question, because I haven't done it yet. So, but,
maybe I can tell a little bit about depending on the core material. If is the core is it laminated?
Yes, it's laminated.
That's going to restrict the frequency quite significantly. In terms of, you can't go like in the thousands of. I think laminated core usually have like the best performance around 400 hertz.
Okay.
That's usually that's my experience. It depends on the coils, but lamination will usually bring it down to around 400 or 500 hertz at the best performance.
Yeah.
But
Ayvind,
if you, sorry.
Ayvind, would you like to join us on this coming Monday's technology meeting? So you can help point out all these details to perfect it. Would you, Pontus, would you want Ayvind to help?
Yeah, sure.
Yeah.
everyone is.
Okay. So Ayvind, if
welcome.
you could just type your contact number here or Skype name on the chat, I will contact you and I will let you know what time the meeting starts on Monday, technical meeting. And that goes same with anyone here in this group, in this meeting here. If you have deep technical knowledge and you want to help out the team here with the prototype, please do same. Because we have a meeting every week, every Monday, to perfect the prototype.
Yes, you are welcome.
Yeah.
Cost on this, the prototypes are going to run probably around 400 euros, 400 bucks to 500 bucks at this point.
Yeah, something like that.
Well,
maybe
it'll
a
get
little
better
bit
as
more.
time goes on, but yes,
Yeah.
it's reasonable for an R&D project in that price range.
Mm.
Mostly, your question is that that's your machine it yourself, a lot of it, but it isn't going to cost you that much more to have the other machining done. It's fairly straightforward.
Yeah.
Sorry, it's me typing. I'll mute myself.
What would be nice is if we end up with a standardized protocol where basically the three-phase motors are identical. You pick those off of a trusted supplier or approved supplier, the ones that know what we're doing. Then the extra parts that it takes to fit it from one to the other, we might be able to have kits eventually being manufactured in country, so that it's just a simple assembly. In the case of Pontus's one, he's using an old generator, and it's really its format is not the same as the newer gas-driven generators. So those parts that he's manufacturing are specific to his build.
Yeah.
And when we get into used wash machine parts, you may end up with several different size motors, and so it's going to be a little bit more confusing to adapt, to be able to get a kit, generally speaking, to couple these things together.
Yes, you should check out Patrick Kelly's book. There are Arduino codes there, and they will work, that we know.
Mm-hmm.
There are also some other gate, a gate driver incorporated with MOSFETs that probably can work also, but we will have to look into that before we say more.
Currently, we're working with the Arduinos in the build. The Raspberry Pis are also available, but we don't have the protocols, and the wiring configuration is different.
Okay.
Even though the Raspberry Pis are a little more robust, both in memory and for functionality, it's a different creature.
Mm-hmm. Right,
and we're sticking
Patrick's website.
Yeah.
And if you scroll down to chapter 32, yeah, Patrick, I'm doing this. Patrick's still with us here. Yeah, chapter 32. Just click on chapter 32. You will see how Patrick puts it together. Yeah, carry on, Fraz. Sorry to interrupt you.
No problem.
Oh, there you go. Patrick, do you want to speak up about this? There you go,
It's always
Patrick.
a question of whether or not you can hear me.
Yeah, we can hear you, Patrick.
Yes.
Okay.
Do you want me to stop sharing so you can scroll
No,
down
no.
yourself and whatnot? Okay. You want to share? Okay.
That's okay. There's no problem.
Mm-hmm. What do you want to address now? I scroll. I'll be your teaching assistant.
No, what I wanted to ask Pontus is the actual coils in the drive motor.
Yes.
Do you have them wired in parallel or in series for 400-volt operation?
They are, I think they are parallel. It's a Y
I believe so.
configuration.
I thought they were parallel, but I've had people query it.
Okay. I will have to check that, but I think they are. It's 3 and 3, just like you have in the chapter 43. What I know.
Okay. Yeah, on the Buie-Morin demonstration video, he shows that the speed of rotation of a 3-phase motor depends both on the setting of the controller and on the voltage supplied. He can raise the speed of the motor by just increasing the voltage applied to the motor itself. So you have both of those things involved, but you are governed, as far as I can see, by the speed of rotation of the alternator that you're using, typically 3000 RPM. Now, to get 3000 RPM with a particular set voltage, you have to adjust the speed of the Arduino, which is button controlled, not a problem. But it's not going to get up as high as people are talking about. I mean, 3000 RPM is not all that great, especially if you have the thing itself, the actual drive to the alternator directly coupled to the motor drive shaft. I mean, there's no difference there. You can get a variation if you use pulley wheels, but typically people prefer to have it straight through if they have the skill to do that.
Yes, of course.
That's not easy to do, of course.
It's doable. In my case, I will have it straight through because my generator is 1500 RPM or 1800, 60 hertz.
But then you're a skilled operator anyway.
Yeah, maybe so. But we will provide also for those who are not so skilled to go to a machine shop and have it made up.
Yeah, sure. But I was talking about the alignment, which the machine shop will not do for you. But you're a skilled operator.
Yeah, okay. But you can demand alignment also, so that will of course affect the price, maybe.
Yes, very much so, because you've got to align vertically, horizontally, and axially. So you've got 3 separate planes that you have to align exactly in. Otherwise, you're going to get a lot of vibration when the thing is running fast, which it will do.
Yes, it will. But there are ways to measure that and so on.
Yeah. You were saying also that you want to use 3 P-FETs rather than 6 N-FETs. I don't myself see why that is, but you're going to design a particular interface board and share the circuitry, which would be fine. The actual original design used 6 N-FETs.
Yes, it does. And what I recall from Thomas is that you have to have a diode on the one of them
yes,
to make that work. But the concept I shown on the screen, it has the future, so it will work that way also.
Yes, indeed. Yes, I've had people pick up on the need to have diodes in the link between the Arduino and the three-phase motor. And so I've adapted the design slightly. The thing I put out the design is really only introductory. It's not intended to be the final be-all and end-all of the thing. I'm relying on your actual tested design so that we can produce a properly documented end result, step by step, after this thing is built.
Of course, and we will do so.
Yes.
I think people are concerned about having to do all that machining, that they don't have the tools to do it.
If you buy a new generator, the only machining you have to do is the coupling. And you have to make it the key or what type of shaft you are facing.
Yes, but your local steel fabrication shop can do that quite quickly and quite cheaply for you. You don't need the skill.
No, you don't.
Or the equipment.
You maybe need to bring the generator to them.
Oh, yes.
You can measure the shaft precisely.
Yes.
And make it the way you want.
And the machine shops will have better tools for measurement than a lot of the homeowners will have. So in that application, taking it to them and say, mic it out and, you know, put it together, you know, make the part so it'll slide together nice and snug, and they will.
The link that I have in the paperwork to the Morin supplier of pre-machined parts appears to be a con artist, as far as we can tell. I don't think Morin himself is involved in that, but the way that they're going on when somebody asks prices from them is a very strong indication that they're not on the up and up at all.
No. What I found out was he had a drawing on the coupling also, but the measurements, they were not correct.
Yeah, that's something that can be adapted quite easily.
Yeah.
Ayvind, and as Ayvind was asking who has the Arduino code, Sergy is saying, check out Patrick Kelly's book, chapter 32. You have it there, right?
Exactly. It's already out there.
Yes, it's downloadable as a single code file off my website.
Thank you, Patrick, for doing all that.
Yeah.
There's not much involved.
No, it's one of the simplest codes I've seen for drivers.
And many apologies for keeping you up so late, Patrick. And Pontus as well, I think.
It's only 10:30 yet, due to the summertime.
Due to summertime, yeah, it's supposed to be 10:30 now. Anyway, Pontus, you're gonna get your ears twisted by your wife.
Yeah, sure.
So we got to hurry along.
Yeah, okay. I think that's all for today. So.
Oh, cool. Right. Is there anything else anyone wants to say? Any unfinished business before we wrap up the meeting and adjourn it? Patrick, is there anything that you want to add to this?
Yes, I want to say thank you to Pontus.
Oh, thank you to Pontus, everyone. Thank Pontus for doing all this hard work.
Thank you.
Thank you, Ayvind, for adding in some technical details and help as well. You're welcome to the Monday meeting. Sergy, you'd like to join as well? Okay, I've taken note of your email addresses. Thank you. And Vince, yeah. Okay, right. I must apologize that this meeting has dragged on a bit, 2 sessions, but everyone was all ears in the first session. Jared was speaking, bringing forth so much of the disclosure information as well. It is disclosure, isn't it? I mean, we're talking
In a
about
way, yes.
attention. Yeah. So, folks, if you're listening to this, and this is the second session, you go to our first session on our YouTube channel, and please remember to subscribe. And if you've got some extra money, pay forward, because we don't even have. We're so broke here. We don't even have money to pay for our Zoom. And James kept telling me to ask for some donations to keep the Zoom room subscribed, so we don't have to jump out of the Zoom room and get kicked out every 40 minutes. And we're lucky this time. I think it's because Jared's speaking. So we have a free, unlimited time for this one, which is a rare thing that they do a promo with Zoom, right, James? James, thank you so much for sponsoring FESIG Meeting thus far. Oh, no, you ran out of money to pay for the subscription, but you did
so
pay for
I paid for last year, the whole year, and so we really need some more people to donate. I mean, I'm willing to donate again, but I'm hoping other people would join in, so it's not just me.
Yeah, it's not fair, really. And me, I've been paying for 3 years for the the hosting of the website and webmasters and everything. And so, you know, we ask you to pay for it. This is very good work, you know it. I mean, we got everybody who's in the know coming in to talk and to teach you and to put things together so we can go forward and we can ascend with Jared's celestial medical baits as well, celestial chambers. So
The Zoom software is $150. We just need about maybe 10 people to donate at least 10, 20 bucks. That would really help us out with our goal.
Yeah, I need a couple of $100 to keep the websites and the webmasters, the server host going as well every year. Yeah, so please
donate $50.
Pay forward. Yeah, pay forward if you can. Yeah. Thank you so much. Okay, so Pontus, any last say for this?
No, I think we can adjourn this meeting.
Well, why don't you tell people how they can donate?
Oh, go to FESIG site. Okay, I'll share screen.
Yeah.
And hang on a minute. Let me just
share. To make it as easy as possible, because when it comes to money, it's kind of difficult to.
James, yeah. Okay, so I'm gonna share
press
screen.
That button to donate.
Yeah. Okay. So well, if you go to FESIG site, truevisionofpeace.com//FESIG.html, okay, and you will see a button, donate. See, it's so clear. Mouse over and just pay forward. Thank you very much. And please join us. Click on this join us button in order to be in the database where you will receive a formal invitation to join all of FESIG meetings, as well as to receive reports on our meetings. Okay. And don't forget to subscribe to our YouTube channel, because we need your subscription in the YouTube channel in order to grow. Right. So.
And also Facebook is also an option if you use that.
There's an option for yeah, in your Facebook, I think you will see a donate thing, and then you just punch in FESIG. I don't know why it comes out like that, so never mind. I'm going to stop sharing.
I think you need to put a more prominent button on your website, where maybe even at the top where it says donate now, or even on the home page right in the front. Mm-hmm. So just to make it as easy as possible.
Yeah, like a pop-up or something. Yeah, I will ask Charles to help me do that. Yeah.
Yeah, even at the top of the FESIG page, it should be right there. Mm-hmm. Not a little tiny button.
Met Charles just now. Yeah, so Charles, fantastic. He helps out. As we speak, you know, he's coming out with the new codes for me to use. Thank you. So from now on, our website's going to be updated and looking better and more navigable, easier to browse. So there you are, folks. And there being no other business, now this meeting is now adjourned. This 63rd FESIG meeting is now adjourned to the 64th meeting that will fall on the 1st of May. It's the first Wednesday of the month. So I would say good night, everyone in Europe and the UK. And a good day to you anywhere in the world. And thank you so much. Namaste, namaskar, and kisses to all of you, my brothers and sisters of Sisters of FESIG. Thank you. So we'll meet again. Okay.